autonomous trucks and intelligent roads. Think about video games right now and think about Pong when you first started. We're in early days of Transformers actually being in our midst. And right now, long-haul transport and logistics is a massive industry, absolutely massive, trillion renminbi industry, multi-billions. So our next speaker's company has upended, disrupted this industry using data analysis, self-driving, and some dynamic tech. Some really amazing cutting-edge stuff coming out of Dalu, the big smoke. So please give a warm welcome to the CTO of Yunmanman, Dr. Wang Dong, everybody. Thank you. Come on up.
Hello, everybody. I'm Wang Dong from Yunmanman. I'm so happy to come here to share with everybody about my company Yunmanman and what we have done in intelligent roads and autonomous trucks, what we have done right now. Firstly, let me introduce Yunmanman. In Chinese, Yunmanman has a very good double meaning. The first meaning is that the trucks are always running on full load. The other meaning is the truck drivers are very fortunate, have very good luck, they can earn a lot of money. This is a service for dispatching transport capacity. Owners of goods can send goods efficiently at a low cost. The whole platform is very easy and you can find your goods very easily. And through the dispatching engine, the scheduling engine, we connect our drivers with our good owners. And we also offer other value-added services. For example, insurance, putting petrol into the car, financial services, and other ETC-related equipment. Through all this series of services to lower the cost of logistics and increase the safety of the goods, protecting both the driver and the goods he is transporting on the road. These are the functions of Yunmanman. After 4 to 5 years of development, in China, Yunmanman is the largest transport capacity dispatching platform in China. And we cover many cities, including 330-something Class A cities. We have roughly 5.2 million driver users and 1.25 million consignor users. And every day we have 7 million pieces of cargo transported per day. This is a very big industry. Every year there would be 120 billion trade volume. Through our smart transport capacity scheduling engine, we can move from manual scheduling and upgrade it through our system, through artificial intelligence, to smart scheduling. This is good in terms of saving fuel costs and reducing carbon emissions. There are two scenarios here. First scenario is that a driver has to drive to a logistic park and he has to stay in that logistic park finding his goods for 2 to 3 days. Perhaps it takes about 10 kilometers of driving to get to the logistic park, but actually getting to the logistic park, that 10 kilometers is meaningless. And sometimes, even after driving to there, they cannot find their goods, so they have to drive back to their original city they came from. That is, again, waste of 10 kilometers. So this first scenario of useless driving, we can replace that. We can eliminate that. We can complete the process for finding the goods on our platform, greatly increasing the efficiency and greatly reducing the probability of driving without goods. If meaningless driving, once it's eliminated, you can save about 10 billion American dollars in fuel costs every year, and 33 million tons of carbon emissions are reduced. So we have the largest road logistic database, and then in this database we include data of the drivers, of the trucks, of the roads, of their driving habits. Through this kind of big data, we can better serve our drivers and also expand to new businesses. We can help our industry and the government to perform smart tasks. Let us get back to our original topic. Autonomous trucks and intelligent roads. So in this regard, we have mainly 4 major directions. The first one is level 4 autonomous truck driving. The second is platooning. The third is customized trucks. So let me explain customizing trucks. Customizing trucks, by saying that I mean that we have OBD boxes inside the trucks. We use those boxes to collect the data. For example, collecting GPS data, collecting the engine status data, and collecting the logistic data in order to help the driver to better learn about his own driving habits in order to better drive the trucks. That's what we mean by customized trucks. And the other one is new energy trucks. So right now, we are already in the development stage of level 4 autonomous truck and platooning. And the rest, we are just starting the project and we are studying it, we're researching on that topic. Let me show you a video of level 4 autonomous truck driving.
Okay.
This is a test on the highway. Probably you have noticed a lot of sensory machines are used here. For example, various cameras, laser radar, and a microwave radar. We use technology which combines these various sensory machines. And through our neural network, we train the program in order to detect what is on the road, detect the obstacles and the lanes on the road, and also the other trucks on the road. We can recognize those trucks. We can predict how the truck should move, how they will move. These are various technologies we use on the highway. The next scenario I'm going to show you is autonomous driving on the ports.
Okay.
Perhaps everybody has already noticed that the scenario in the ports and the highway is different. We attach the sensory machines at different locations because in the 2 different scenarios, there are different requirements on the calculations. On the highway, we put more sensory machines on the top of the truck, more cameras, in order for the truck to see further along the road, a longer braking distance. As for in ports, we don't install them on the top of the truck. We install those sensory machines on the bottom of the truck. So that way, it increases the accuracy of steering the truck itself, and then we can avoid lower obstacles. This is the difference between the 2 scenarios that I was showing you. Actually, we're not just a tech company. We're also an operations company. As we have introduced, we are the largest dispatching platform in China. And in the dispatching, apart from sensory, locationing, and those core technologies that I've just mentioned, as an operator, we also have our own distinct advantages. Firstly, as a logistic operating company, we have connections with the universities, with the truck manufacturers, and with the relevant authorities. We cooperate with them, and we have deep cooperation with the truck manufacturing companies. And also, chip is very important in the autonomous driving development. We have many in-depth collaboration. We can import some algorithms to the bottom layer of the chip, which helps our technology. We have widespread cooperation with the AI chips, the newest AI chips. Apart from that, another advantages that I think we have 5,000 trucks where we own and operate. Apart from the specific trucks we test our technology on, we can also collect and test on those 5,000 trucks. We can use simulation where on the one hand we have a human being driving the truck, and on the other hand we have a human being driving the truck. We can compare and contrast and learn from that and detect the problems inside our algorithms and models. Another point is about the customized trucks I mentioned. We cooperate with the truck manufacturers, and we sell our trucks to more truck drivers. Every year we sell tens of thousands up to hundreds of thousands of new trucks. These customized trucks can help our drivers reduce oil consumption, reduce petroleum consumptions, and pay attention to their own driving habits. For example, in a specific highway, how do they drive? For example, in certain more difficult roads to drive on, they have more conservative ways of driving. In other easier roads, they might drive quickly. And also, for truck drivers with different goods, they have different driving habits. Based on the different drivers and their various differences, we can develop rules and algorithms and better improve our technology. As an operator, we can increase the speed of commercialization of our technology in collaboration with our tech side. Currently, we have R&D in Silicon Valley, Nanjing, and Beijing. Next, let's talk about platooning. This is an area we are prepared to enter because platooning would happen sooner in terms of technology, and we can see some very obvious applications of our technology. For example, in China at the night, many large trucks drive on highways at night in China. So there are relatively less vehicles on the road then. It's easier to maintain the platooning. This has a very high requirements for the technique of the driver, but in platooning, we no longer require that, so there's a lot of commercial value to be had in this platooning technology, especially for the trucks in second in line, third in line. We can reduce petroleum consumption by 5 to 10%. In our research of platooning, we do not only communicate between trucks and trucks. Apart from that, we have more V2 access technology as well. Since 5G is currently expanding and testing in China, we can make use of the 5G technology. Not only do the vehicles communicate between themselves, the vehicles can communicate with other objects on the road. For example, objects which are not our trucks. Those communications will require 5G technologies. For example, on the side of the roads, there are some smart road objects. They can inform the trucks of the best driving locus. For example, we can use C2Y trucks we can only allow them, C2Y function trucks, to join the platooning, and then we can see how they are changing direction or reducing their speed, applying brakes, and then all of those data can be communicated and used in our technology. Of course, autonomous driving and truly driverless driving, there's still a long way to go. Not only tech companies and also the factories who manufacture chips play a role here. As we are pushing for this development, we can see there are several issues which are more important. Firstly, the computing power of chips. For example, in truck driving, we need a 50T level of chips with a 50T processing power. And also the power consumption is high. So currently, for driverless autonomous driving, this is one major obstacle. For example, in different weather scenarios, in different weathers, the cameras may have difficulty detecting the correct input, sensory input. When it's, for example, when it's raining, can it still receive light accurately and detect sound accurately? Would the laser radar work properly in various road situations, such as very dusty roads? This is the weather situations. And finally, there's also the hardware related to self-driving vehicles. We have to minimize the size of our driving vehicles. Right now, we're installing them on the external side of the car. We want to put them internally so they look better. We do a lot of large-scale testing and then to satisfy industry standards. So it would not be the case that it runs for many, many thousands of miles and then it breaks down. So we would detect that in front of them. We have a standard for those cars to adapt to in order to keep them safe. For example, right now, in order to fully equip a driverless truck, you need about $100,000 US. But right now we're trying to lower that cost to $5,000, $10,000 US to fully commercialize driverless trucks. And finally, there's the model's accuracy and the system robustness. We have to increase the software's model accuracy, for example, the entire system's robustness, so that in various corner cases, various special cases, they can still operate properly. Therefore, the whole driverless vehicles, in the situation of trucks, there are many, many challenges ahead. This is simpler than scenarios in the urban areas because we drive primarily on highways. There are not too many obstacles, not too many accidents. It's relatively simple. But we still need to fix a lot of issues around accuracy and confirmation and everything. But we are very happy to see that the entire industry is developing quickly. For example, the chips are currently testing newer and newer AI, and then they implant certain algorithms directly into the chip itself. So we believe that these technical issues would be solved very quickly in the future. Finally, what I want to talk about is in the area of smart logistics. Perhaps driverless autonomous trucks is only part of that. Before that will happen, in smart roads, intelligent roads, that will happen first. That application scenarios will be here first. For example, we can use IoT and AI combined with machine vision technology. Those technologies can be applied to many scenarios. For example, currently, via internally installed cameras, we can see if the driver is driving tired. If the driver is tired, we can warn him, and this will greatly increase the safety of drivers. And also, in terms of the situation of the road and in the logistic parks, we can use cameras to detect whether there are safety issues inside logistic parks right now. Apart from the application of vision technology, I think deep learning and new input, and intelligent scheduling will have a lot of application in our engine. For example, in our scheduling engine, we will use more deep learning technology, so the drivers can access goods quicker. With the help of our app, drivers can plan ahead what goods they need to pick up for the weeks and days to come in order to change their behavior into a planned and scheduled behavior, increasing the efficiency of logistics. And finally, there's the APC. Right now, we can use voice recognition software as an input method. This is very important. Right now, many drivers stay in contact with the good owners through phone. They would have to write down what they say with paper and pen. This is a very low efficiency and lengthy process. However, through voice recognition software, to place an order, all the good owner has to do is to speak what he wants to communicate to the driver, and then through this modularized piece of information will be presented in its entirety to the driver. All he has to do is accept the app and see the message. Voice recognition will gradually be upgraded to a smart customer service. So if the driver has a request, they would talk to the AI customer service, and then that customer service will understand better his habits and what kind of goods he wants to move and what he wants to do, and serve him better that way. Finally, better road logistics is our mission, and we will continue to work hard to make public logistics smarter and better. Thank you, everybody.